Hi everyone! In this video, we'll try to find the answer to the question, please explain the testing principle, absence of errors is a fallacy. Let's begin. Absence of errors is a fallacy is the last principle defined in ISTQB, and as with other principles, it sounds simple to explain. But in fact, it is common to be ignored by testers. Let's learn the consequences of ignoring it. And we start with the ISTQB explanation. If you don't know what is ISTQB, the link to its website will be provided in the materials for the lecture. According to the ISTQB, testing all specified requirements and fixing all defects found could still produce a system that does not fulfill the user's needs and expectations. This wording should remind you where we started, the definition of the testing process. In the scope of the definition we specified, by performing these activities, testers determine whether the products meet the specified requirements and end users and stakeholders' needs and expectations. The first part of the sentence is related to verification, and the second part of the sentence is related to the validation. A lot of testers do only the verification and totally forget about the validation. These theoretical words are better explained with the help of an example. And we can use the example we provided in the video. Early testing saves time and money. Let us remind you of the bug which was in that video. So we had very simple requirements: create a registration form for the site. The requirements are simple, clear, and understandable. Therefore, as a tester, we did not have any questions and started writing test cases. The first test case was valid to check if it's possible to register, and then we wrote a lot of invalid tests, where we enter bad data in fields. This is called verification, and this is the activity that all testers don't forget to do. The definition sounds like this: confirmation by examination and through the provision of objective evidence that specified requirements have been fulfilled. The definition sounds complicated, but its meaning is simple. On many projects, the requirements are vague and unclear, and the testers ignore it and just test what they have. How we did it in this example. We have not specified which fields are mandatory and which are not. How many characters can be entered in each field. We just started testing and wrote one test to check the requirement. The test checks if the user can register. That's all. Verification is done. We have requirements and we have a test that checks them. What happens next? The coding phase. Developers create the form on the website, and once they finish with the form, we can start running test cases. And we start with the first test. Enter valid data. Click on the Register Now button. And we see that we were able to do it successfully. Now it's time to pass other tests. And all tests passed successfully. We are satisfied with the results and we say that everything is tested. As you can see, we have done a lot of work. But all this work is the verification only. And this is exactly how it looks on most projects. We verify that users can register on the website. What happens next? It is time to release the feature to production, so the real users can register on the website. And everything is tested, so all should go smoothly. But when the feature goes into production, people are unhappy. Many people are unable to register. Or they are able to register, but they write to technical support. What happened? People are unhappy because we ask them for their first name and the last name. Someone has only first name, someone has complex first names, and many other scenarios. For some products, it doesn't matter. For example, for credit cards, a person must enter their first and last name. But not in our case. Let us remind you why we learned these principles. There are two types of testers. The first type is testers who don't know the testing principles, set unattainable goals, and unrealistic objectives. And the second type is testers who know and take advantage of the testing principles, set achievable goals, and realistic objectives. And in the scope of the principle, absence of errors is a fallacy, we have two very important goals to set. The first one is to verify whether all specified requirements have been fulfilled. We have achieved this goal during the testing activities. And the second goal is to validate whether the test object is complete and works as the users and other stakeholders expect. And this goal we ignored. Let's check how the validation process looks like. Validation can occur at any stage of software development, but in our case, it was best to conduct it at the first stage, and the stage of defining requirements. First, it starts similarly to what we did before. You familiarized yourself with the requirements, but instead of writing the test cases, you need to start with the questions. What kind of questions? What is this product? Who will use it? What devices will be used? All these questions are oriented on validation. The definition of validation is complex and unclear, but we will provide it anyway. Just as an addition, we will provide another sentence, which in our opinion explains the meaning of these complex words. We also need to test to see if the delivered software and system will meet user and stakeholder needs and expectations. And the keywords in the definition are user and stakeholder. We need to know what product we are building and for whom we are building it, and how the stakeholders want to earn money on it. Only once we have an understanding of those things, we can start testing. Otherwise, we do only the verification. So, whom do we ask these questions? On each project, there is someone who can answer product-related questions. In Scrum, the person is called the product owner. We as the tester ask questions, and the product owner provides comprehensive, understandable, and clear answers. And now that we have all the answers to our questions, the quality of our testing is higher. Before, when we wrote our test cases, we used the name John Doe, but now after a conversation with the product owner, we know who are the users of our application. So we write a list of valid names. You are the expert, and you do what all the experts do. You Google. You read articles related to personal names around the world and you find some interesting scenarios. It's time to go back to the product owner and have another meaningful conversation. You provide the results of the research. There are a lot of personal names which can't be used in our form. The product owner hears your concerns and provides the solution for the issue. That is an example of validation. The validation process is more complex than the verification. For verification, you need to read the requirements and check if the developers coded the product according to the requirements. For validation, you need to read between the lines. The result of the validation is that the product owner updates the requirements, that they correspond to what was decided during the last conversation. So, developers code a new form, with one field, full name. After that, we carry out the verification process the same as we did last time. Only now we don't have two fields for the name, but only one. And then we release the product to production. All users can register with their names. So they are happy, and we did our expert tester job very well. This is the implementation of the principle, absence of errors is a fallacy. We did not find any bugs in the first scenario. Users' problems were not related to bugs. They were unhappy with the product itself. We were making the wrong product. It didn't meet their needs and expectations. In the second scenario, we were building the right product, so the users were satisfied. You can pause the video and read the principle explanation again, but its basis is that our work as a tester consists of two main goals. The first goal is to find as many bugs as possible. And testers often forget about the second, no less important goal. Check if we are building the right product. Does it meet the requirements and expectations of users and stakeholders? And that is our answer to the question. Please explain the testing principle. Absence of errors is a fallacy.